Okay, so now moving on to the next worksheet. I'm just going to go through some of these practice examples with you. All I really want to do is identify in here, going down the list, which law of motion that this is actually referring to. Now, I'll admit, even I find that at times you could argue one way or another with these because these are Newton's laws of motion. Whenever an object's moving, these laws actually do apply, or if an object is actually at rest and you're going to try to get it to move, these laws do apply. So let's just go into the first one. A climber pulls down on a rope, causing his body to lift upwards and rise along the rope. Okay, so what I mean by that is you could easily say that this is either Newton's first, second, or third law of motion over here. You could say, hey, you know what? An object at rest stays at rest unless acted upon by an unbalanced force. It could actually apply to Newton's second law of motion. I would think that as soon as he's increasing his force, his acceleration will actually increase as well, moving himself up the rope. Or you could actually even argue, hey, you know what? Maybe this is the third one. For every action, there's an equal and opposite reaction. He's pulling himself up the rope as just like his body weight is actually pulling down on him. So there's an equal and opposite reaction going on there. I could actually, I'm not even 100% sure on this one, but all I want to say is that you could argue probably multiple ones on these, and that's the reason why I give this as a classwork assignment for the students to actually think about and not to grade whether or not it's right or wrong. So over here, maybe I'll actually just say that this is Newton's third law of motion. The second one, for force is equal to mass times acceleration, obviously that's referring to the second law of motion. Two bumper cars collide into each other, and each car jolts backwards. Okay, so this is probably for every action there's an equal and opposite reaction, right? When you give your friend a lift on your bike, you have to pedal harder and faster to keep the speed, acceleration, as you had before when you were on the bike alone. Okay, so it sounds like when you give your friend a lift on your bike, okay, so you're increasing your mass size and you're having to pedal faster to actually keep the same acceleration, speed and acceleration. So this sounds like it's referring to which one? I would say it's second law. So you're increasing your mass size, you're having to apply more force to actually maintain the same acceleration. I would say that that's the second law of motion. For every action, there's an equal and opposite reaction. Sure, that's just the definition of the third one. A smaller cannonball leaves the cannon much faster than a larger, heavier cannonball. Okay, so that sounds like right off the bat, we're dealing with the second law of motion, right? When you're standing in a subway train and the train suddenly stops, your body continues to go forward. Okay, so is that for every action there's an equal and opposite reaction, or objects in motions tend to stay in motion, objects at rest tend to stay at rest unless acted upon by an unbalanced force? I would actually say it's that one right there, referring to the first law of motion. Okay, so I'm pretty sure you're getting the hang of these, and that's all I really want to do right now. So continue these. I'll also attach a answer key to this as well. So do your best, and good luck to you.